I'm in love with your body.
Well, in this problem of stoichiometry, we have potassium chlorate, and it said that by thermal decomposition, by heat, it decomposes into chloride, potassium, and oxygen. The problem informs that there are 5 grams of chlorate potassium, which are not pure, are 95% pure, and has 83% as reaction yield. The item A asks for the gram that will be formed of potassium chloride. The first step is to adjust the reaction. We have 1 potassium, 1 chlorine, 3 oxygens, 2 oxygens here multiplied by 3, and here by 2, for the oxygens to be 6. So we put 2 oxygen here, 2 potassium, because if we don't do it, we modify the chlorine potassium. Now we have 2 potassium, 2 chlorine, and 6 oxygen on both sides, balancing the equation. We start with 5 grams of KClO3, which are not pure. We know that in every 100 grams of impure KClO3, only 95 grams are pure KClO3. Well, once we calculate the pure grams, we move to mole. One mole of KClO3, which is potassium chlorate. Well, let's calculate. It would be 39 plus 35 with 5 of the chlorine plus 16 times 3 oxygen, which gives 122.5 grams, which would correspond to 1 mole of grams. The next step is to observe the stoichiometric relationship between what the problem gives me and what he asks of me, right? That means that for every 2 moles of chlorate potassium, we have 2 moles of potassium chloride. So we put it here. The conversion tells me that for every 2 moles of chlorate potassium, we decompose, we have 2 moles of potassium chloride. And now let's move to gram, which would be 1 mole of KCl. And now we calculate the potassium, which is 39, and the chlorine, 35.5. Then we have 74.5 grams of KCl. Then we continue the calculation. Since it's 83%, then we multiply by 0.83, which corresponds to 100 grams. Let's make the calculation. Well, according to the calculation from this equation, the final value corresponds to 2.397 grams of KCl, as required by item A. Item B asks me for the oxygen volume measured at a pressure and temperature of 720 mercury minutes, okay? At a temperature of 20 degrees Celsius. Well, we know this pressure is 760 for the atmosphere. The calculation of the temperature has to result 273, so that everything goes well. Well, the process was the same. We would start from 5 grams, we would calculate 95%, and then we would go to mole. We would have a molar reaction, but now we would have a molar relationship between potassium chlorate, and if it is 1 mole of KClO3, we get 3 moles of O2, right? Since we already have the moles, we use the formula PV equals nRT, knowing that the V, volume, equals N, number of moles, times RT over P, being 0.082 minus 293. Temperature in Kelvin over 72. Pressure over 76. With this, we will obtain the volume of the oxygen. Let's calculate. If my calculations are correct, the result is 1.475 liters of O2 in grams. Okay, that closes the resolution of our stoichiometric calculation. Thank you very much.